All right, welcome Algebra 1 and Math 8 group to week 6. All right, and we are going to talk about factoring because the Algebra 1 students are going to need to factor. So we'll all do that with them. And then we'll talk about lines and best fit. That's something you actually do in Math 8 and Algebra 1. Good stuff this week. Try your best. All right, so factoring is the opposite of multiplying. Opposite of multiplying. It's backwards. And so if you are confused on this, the first thing I want you to do is go back and check your scores on multiplying polynomials. Did you do it? Do you have a blue start button? Do you have anything less than 100%? If so, do that first, because this won't make no sense if you don't do that first. So when we multiplied polynomials, we drew 4 boxes, if you remember, and we got an answer that looks something like this. There's the 4 boxes. So when we factor, we're going to put these things in the boxes. So we always put x squared first. We put the 24 in the last box. And again, that will be familiar to you if you did the multiplying. And then the 10x, where does that come from? I wonder. That is the combination of those 2 boxes put together. So those 2 boxes put together are 10x. Now, the factoring is trying to figure out what was on the outside of the boxes originally. So what times what gives you x squared? That would be x times x. Also, what times what gives you 24? Well, now that is a bit trickier because, 12 and 2, but also 6 and 4, and also 8 and 3, and also 24 and 1. There's 4 pairs of numbers that multiply to 24. And so which pair do we choose to put here and here? Well, that would be the only pair. There's only one pair that adds to 10. So what you do after you figure out the factor pairs of 24, you add them together. So this would equal 14. 6 plus 4 is 10. It's that one. 8 plus 3 is 11, and 24 plus 1 is 25. So you see, there's only one pair that equals 10. And so it has to be 6 and 4. In essence, if the original multiplication problem was x plus 6, x plus 4, then the answer would be x squared plus 10x plus 24. And so the answer to this is the original multiplication problem. X plus 6, x plus 4. And so, read the hints, replay this if it didn't all make sense, and give it a try. And eventually you'll get the hang of it. The tricky part is when, we have the negatives and the positives, then that takes a little bit. But I just want you to practice and kind of organize which ones have which. I could just tell you, but I think you can figure it out too if you try. So here they have drawn a box here, and they've given us one of the factors. So this is kind of like the same thing, but a little easier because they already told us x and 8 is on the top or side, and x squared negative 72, and this is a negative x. So that means that these 2 boxes have to add up to negative 1x. So that means that we need a negative here, and we know that x is here. The question is, what times 8 is 72? Well, that's 9. 9 times 8 is 72, and negative 9 times 8 is negative 72, and that is the width, x minus 9. Don't be fazed by that one, because it's a little bit easier than something like this. And of course, post in the organizer. Now, when we get to something like this, the number one rule about factoring is look for the GCF. Look for GCF, always first. The one that we just did had no GCF. But this one, what number can we divide 4, negative 4, negative 28, and negative 48 by? Well, we can divide those all by 4. Those are all divisible by 4. So we call, because we can divide them all by that number, it's called the greatest common factor. Well, any number you can divide them all by is a common factor, and the biggest one is the greatest common factor. So what we do is we divide them by the greatest common factor, because that's all we can do with it. So when we divide and put it out front, this would be just x squared. A negative and a negative is a positive. 28 divided by 4 is 7x, and 48 divided by 4 is 12. Again, a negative divided by a negative. So the formula is kind of like this. GCF goes out front. See that? And then I divide each term by the GCF, and that is what I put inside of parentheses. So give it a try. If you can find your GCFs, it will be so beneficial to you. I promise. All right, and then the next assignments are a little bit less strenuous. Talking about scatter plots. People use scatter plots all the time. So we want to be able to look at data. And if you were with us for missionary math, then we talked about a scatter plot of average offerings over the course of years that you would need to use to get a bank loan. So it's not hard to find an application for this. So what we do is we get all this data, and then we look at it to see if there's a pattern, and it might be a line. If, as I look at this pattern, I see that I can kind of draw a line through it that kind of fits the behavior of it. It's kind of going up, you know, a little bit. This is down here, and then this is up there, and then there's some points on the way in between. I can't draw a very good line, but anyway, so what is the best? I would say positive, because positive means going up. Separately, this is not true of this graph, but it could have a negative correlation, which means it would be going down. So that'd be something like this. And then this is a strong correlation, because the points fit pattern well. And we could have a weak correlation, which means points loosely fit the pattern. So not all data is as strong as this, kind of close together. So, and then linear, that's the other thing. So is it linear or is it non-linear? Linear means line of best fit. Sometimes the data might have a pattern, but you know, something like this, that's not a line. That would be non-linear, a non-linear association. So I would say this would be a positive linear association. Okay. Then 2 more here. A company that makes an exercise machine asks some of its recent customers how long they have owned their machines and how many hours per month they currently use their machines. Which of the following is the best estimate of the average change in hours of exercise per month that was associated with a 1-month increase in ownership? So I think they're trying to say that as they own their exercise machine, they're not using it as much as it gets older because they lose their willpower. All right, so what happens? Length of ownership. The 1-monthers are using exercise per month 9 hours. So, the average one, if you own it for the first month, on average, you're exercising 9 hours, 9 days out of the month. But then by month 3, it's down to 7. By the time you get to 11 months, you take it out a couple of days of the month, right? So what was the question again? What's the best estimate of the average change in hours associated with 1 month? So average change is the slope. What we can do is we could just pick 2 points, 1, 9, I'll pick 1, 9. And how about 11, 2? And we're just gonna see which one we get the closest to, but I'm gonna find the slope. Do you remember how to find the slope? It's y2 minus y1 over x2 minus x1. So not 2 minus 9 over 11 minus 1. That'd be 10, negative 7. So I got negative 7/10. So whoa, did that. Okay. So that is a number less than 1. 7/10 is negative 0.7. So which one of these numbers is closest to negative 0.7? Not 5, not 3. This would be negative 0.75. 3/4, you should know by memory, is 0.75. And you should also know by memory 1/3 is 0.333 repeating. There's certain decimals that we use all the time, like 1/2, 0.5, right? So you want to know that. So this is negative 0.3 repeating. So I would say, even though we didn't get exactly 0.75, we got 0.7. I did, and there's only one that's close to that, and that would be C. All right, so statistics requires a bit of estimating and rounding in order to get patterns and relationships. All right, so hopefully you are watching I should have said this at the beginning of the summer even. Hopefully you've been watching one problem, doing the assignment, going back and forth, so that you're not too tired out. By the time we talk about Jacob distributing a survey to his fellow students, asking them how many hours they'd spent playing sports in the past day. He also asked them to rate their mood on a scale of 0 to 10, with 10 being happy. Cool. That's fun. All right, so which of the following linear equations best describes the given model? Well, hey, they already gave us a blue line of best fit. In blue is the line of best fit. Well, that makes this really easy. We just have to know what's the y-intercept. Well, that's 0, 5. That's the y-intercept, which is B. Do you remember that? And then the slope, if we find 2 points, like here, you just draw a triangle, and we go over from 1 to 2. This is 1. Be careful about, I know it's 2 squares, but see, we went from 1 to 2. That's 1. So each square on the x-axis is half an hour. Jacob's trying to trick us. All right, and same thing on the y-axis. Each is going up by half. So that's 1, 2, 3. That's 1.5. So the slope is rise over run is 1.5. So I'm looking for 1.5x, and then the y-intercept is 5 plus 5. And I wonder if you know that 1.5 is the same as 3 halves. So we could also see that. So, but I do see 1.5x, oh, plus 5. This is negative. It's not negative because it's going up. All right, guys. Oh, we still have one more question, and that is this. Based on the equation, estimate the mood rating for a student that spent 2.5 hours playing sports. So now that we have an equation, we can substitute time playing sports into that equation, and we can estimate the mood. See, that's neat. All right, so let's go ahead and calculate this. Jacob is predicting that if you play sports for 2.5 hours, then your happiness will be at an 8.75, 10 being the highest, 0 being the lowest. So you're a pretty happy guy. And you can see Jacob is saying if you play more sports, you'll be happier. I wonder if you think that's true. It depends if you're winning or losing, right? All right, guys, we'll see you on Tuesday. Please have all these assignments complete, have this video watched with notes taken, and of course, post in the organizer. Bye.